Okay. All right. Good morning, everybody. My name's Wes Simpson. I'm your host today for our webinar on expanding applications for RIST technology. And basically what we're talking about is how things are growing in the world of RIST and why more and more companies, end users, large organizations are adopting RIST technology to provide higher quality transport of their signals across all kinds of networks. So what what I'd like to do is first of all start off by, and there's a few people just joining right now, so we'll let them join in. Hello, folks. If you could turn off your video, that would be appreciated. And on the call today, we're going to have three speakers. First of all is Sergio Ammirata, the chief scientist for SipRadius. You want to say hi, Sergio, and tell us what you're excited about today?
Uh, yes, hello. I'm going to be talking about a really unique use case for the RIST protocol today. Be going beyond the normal video transmissions.
Great. And we also have Satoshi Kanemura, the president and COO of 4A Americas. Welcome, Satoshi-san.
Hey everybody, how are you?
Something, are you excited to be talking about something today?
Sure, I'm gonna tell you why we pick up the RIST. What's the reason why? I'm gonna tell you why.
That's great. We're looking forward to that. And closing out our webinar today is Ciro Noronha, who is the CTO of Cobalt Digital. And he's also the president of the RIST Forum and has edited, I think, all or mostly all of the RIST specifications that exist today. Welcome, Ciro.
Hi, folks. I have edited all of them, every single one.
Okay.
So, and I'm not going to talk about how excited I am about RIST because I am excited. I have been for the last 5 years. So today I'm going to be talking about a little bit of look in the past and more of a roadmap, what we're going to do next.
Well, great. So we're looking forward to that. Now, just real quick, for those of you who may or may not know, I wanted to give a quick, elevator pitch on what RIST is. And RIST, R-I-S-T, stands for Reliable Internet Stream Transport. So what does that mean? Well, reliable, RIST supports 3 different error correction schemes. It has capability to transport signals with forward error correction. And in fact, we give some guidance in our specification on how to do that. RIST streams can be used with hitless protection switching, and that as defined in SMPTE ST 2022-7. For those of you who are familiar with that, that involves sending the same stream on 2 different flows and allowing any lost packets to be recovered. And then finally, and probably what RIST is most known for, is ARQ, the automatic repeat request capability, where if the receiver detects that a packet is missing, it can send a request back to the sender to have it retransmitted. With these 3 different technologies that are available, your implementation can take advantage of all of the latest and greatest state-of-the-art capabilities to get your stream through intact from source to destination. Internet, well, that works well in the name, but really internet means that RIST can work on any network, private, public, leased line, whatever you have, and it will work over wireless networks, bonded cellular networks, satellite networks, to and from the cloud, as you'll see in 1 or 2 of the applications we talk about today. So it's really a very flexible protocol with respect to network technology. Stream, we use that loosely. That could be a one-way or a bidirectional stream, large streams, small streams. You can even send ST2110 signals very easily over a RIST environment, and it can be single or multiple streams. So you don't need to have everything bundled into one. You can open up a RIST connection and use it as a bidirectional, secure, and reliable method of transport. I think maybe we should think about changing our S to be secure, because there are a huge number of ways to make RIST signals very secure. And then the last is transport, getting things from end to end. That's what RIST is all about. So our first presenter today is Sergio Ammirata, again, and he's going to be talking about extending the applications of RIST, a technical exploration of a new product that he's going to be launching at IBC called SipVault. Take it away, Sergio. Sergio, you're muted.
Sorry about that. Okay. So repeating myself again, I'm Sergio Ammirata, Chief Scientist of SipRadius, and I'm also a Director of the RIST Forum. In this presentation, these few slides, I will be talking about a new use case for the RIST protocol. Particularly, like was said, I will be introducing this new use case within the context of a new product we are releasing an IBC called SipVault. So let's go to the next slide, please. Okay, so what is SipVault? SipVault is a secure real-time communication platform that we have designed for broadcast production teams. That's our target, demographics. It combines an intercom, real-time text messaging, and file transfers, files meaning multimedia, for example, all in one self-hosted platform. So the idea of SipVault is to address the needs of teams working in dispersed locations, a common scenario in today's broadcast industry, right? So, but unlike platforms like Skype or Zoom, where we are right now, SipVault is self-hosted. So it offers complete control over security and data. Now, we've all seen the importance of this in recent headlines, right? People being arrested, platforms going down for days at a time. Who knows, right? Next slide. All right, so how does this tie into RIST, right? Well, SipVault is the first solution to use the RIST protocol for text and file transfer, right? While RIST is widely adopted and used for video streaming, at SipRadius, we are expanding this application beyond the typical, let's send a video stream somewhere. SipVault leverages the RIST packet retransmission and the low latency for non-video data, as well as the security of it. In addition, and this is very important, the UDP transport nature of the protocol allows for faster file transfer, which are not affected by network congestions. We've all seen how when you try to use FTP to transfer across the internet, the bandwidth or the file transfer speed is never the one that you have on your internet connection. It's much slower. That's a product of the TCP protocol. Because RIST is UDP, we get over that limit. So we believe this sets a new benchmark for secure communication, both in broadcast industry and beyond. So other people can follow and do similar applications. Next slide, please. So how do we overcome the barriers? What were the technical difficulties? So adapting RIST packet retransmission to ensure integrity for text and file transfer, that was a key challenge. We had to meet the low latency requirement across different data types, which is essential, right, for real-time communication, and at the same time, guarantee delivery of every piece of data, because unlike video and audio, we cannot skip a letter or a word on a text or even a fragment of a file. The data has to be there in its entirety. In this communication that we're seeing, when we're transmitting video and audio through this method, if I drop a frame in the transmission or a fraction of a sound, you don't notice this, you don't care. But text and files, you cannot do that. So we were able to meet the challenge using two techniques, right? Because RIST allows for that dropping of packets if it goes beyond the buffer or if you cannot recover. So one technique we use, it's called variable dynamic buffering. And it's already an existing feature of the LibRIST library. We just put it into use. This basically optimizes the latency of each connection based on the conditions of that particular link. So everybody connected will have that buffer adapted to their link. That guarantees the minimum possible latencies for that piece of communication, while at the same time guaranteeing the packet recovery that RIST gives you. The second technique we use, and I'm going to be very brief because I only have a few minutes for my part of the slides, is we added a stateful engine on top of the protocol. Basically, we created data transfer acknowledgement at an aggregate level, meaning an entire text message or file chunks. Once RIST sends the entire content, we double check, is it all there? If not, we fill in the gaps for that aggregate acknowledgement. That gives you the benefits of UDP while at the same time guaranteeing the data integrity. So, and all this we did while leveraging the underlying security provided by the protocol. Underlying security meaning authentication and encryption. Thank you. Next slide. So summarizing, extending RIST beyond video streaming opens up many possibilities for non-video applications. We have been able to push the boundaries of what is possible in secure communication with the REST, offering a solution that is not also reliable, but future-proof. So this innovation could impact industry where secure real-time data transmissions and communications are essential, right? And RIST could be at the heart of that. So anyway, come see us at IBC if you want to hear more about this particular application or the simple product. Next slide. Thank you very much.
All right. Thank you, Sergio. Really appreciate it. Yeah, I'm sure a lot of people will be interested in seeing a hands-on demo at your stand, Hall 5 F.40 or F43. Yeah, it seems like you need like major grid coordinates to find any booth at IBC. It's always exciting.
Yeah.
So and if anybody has questions or whatever, feel free to type them in the chat. We'll go to open mic at the end of our 3 presentations and give everybody a chance to ask and answer questions as you would like. So our next presenter is Satoshi Kanemura, and he's going to be talking about why 4A, a very large, well-known organization based primarily in Japan, but having a worldwide reach, why they chose RIST technology for their applications. Take it away, Satoshi-san.
Oh, thank you very much, Wes. Hope everybody here well. Everybody ready to IBC?
Yeah.
My name is Satoshi Kanemura from 4A America. 4A is offering a lot of solutions to broadcast or corporate live events, house of worship, you name it. But REMI, remote production demand, is becoming very, very increasing at the moment. So we're struggling how we can respond to the pain point our customer have for the REMI applications. And we come up with a solution by having a great help from Sergio on an encoder decoder, and also he recommend me about REST, and we dig into that, and then we happy to decide to adapt the REST for this REMI application. Then let's go through why. Next page. Number 1, why? Everybody looking for audio, video all together. It's sync up together. How that? That's always a pain point everybody asking us. The next page. And REST gonna offer UDP stream, not only just single, it's up to 10 stream you can send it over. And then even audio data as well is in sync. And as you know, UDP, Dante audio becoming very, very popular, and that can be through the UDP stream together. So 10 stream, audio, video, all sync and send it. That's a great solution to everybody. The next question is come up. Is that really secure? I mean, and the next page, I think Wes already mentioned about, we call it military grade security. Nobody can crack. at the moment, everybody worry about some, cracking or, stealing the data, especially the broadcaster is worried about. But RIST offered a great security mechanism. But not only that, packet loss recovery is so smart. So you don't need to worry about any packet loss during the transportation. So that's another response for the pain point. The third one is people asking multicast is possible. Next page. Of course, RIST support the multicast or point to multipoint. That's very important. Some Obitra company would like to send a signal to executive producer or inline producers, many space, or there are so many demands for the multicast or multipoint, and the RIST is respond to the pain point. The fourth one, interoperability. That's always everybody asks. REST is open platform, open standard, and it's just keep growing. Everybody can participate. So you can improve this transport stream much better way and broader adoption already. So interoperability is promised. And then you don't need to worry about no hidden costs. No license fee is coming later. After that, adding some feature, you're going to pay more. No, this is pretty much open standard. Okay, next page. So summary is REST can do audio video sync up together, and the multicast is possible and totally secure, and because of open source and open standard, so no hidden cost. So there are no reason to not adopt RIST, I think, for that, kind of REMI type of application. That's why 4As adopt the RIST. And I forgot to mention that I have to do, otherwise I'm going to be killed, but the 4A going to have a booth at IBC. Stand 2, B50, so you can experience of this encoder decoder in a transport stream by using RIST demonstration at the 4A booth at IBC. All right, thank you very much, Wes.
Okay, Satoshi, thank you very much. And we'll have you stick around for some questions later on.
Hey.
So our third prepared presentation is from Ciro Noronha of Cobalt Digital, but in this case, I think he's acting as in his position as president of the RIST Forum. So take it away, Ciro.
Yeah, my alter ego. So
kind of Bruce Wayne and Batman, huh?
Yeah, well, I'm Batman today, Ciro tomorrow. Okay, so I'm going to talk about RIST roadmap. Before we talk roadmap, we need to see where we have been. So next slide, please. All right, so I said 5 years, actually 7 years we've been doing this. It started in 2017. So the story started in actually February 2017 during the VTrans conference. There was a guy walking around Brick Ackerman and saying, we're going to do something called RIST. Who wants to join? And people joined. And we didn't do anything until actually April during NAB when we had the breakfast at the hotel there. And we decided, yeah, we're going to do something. So we talked about it and designed something for a year. We had an initial interop earlier in 2018 at the VSF meeting at Cisco, actually in the Bay Area. But then we did at IBC, the first multi-vendor interop, first public interop in September 18, and that got followed by in October 18 by publication of TR06-1 with simple profile. And I'm going to make a dig at other organizations, and we can get these for free. You have to pay a penny, just like Satoshi-san said. Even the documents are free. So simple profile gives you the reliable transport. But then what about security? So that was main profile that came out in March 2020. We had a big interop in February of 2020. Everybody implemented it. We got together at the Cobalt office in Anaheim, right next to Disneyland. So instead of going to Disneyland, we did that, approved interoperability, and we published the spec, the security spec. And tunneling that became very flexible. And then we came with advanced profile in 2021. Advanced profile gives you ability to run anything over RIST. Any protocol you want can run over RIST. using advanced profile. But then in 2022, we published the multicast authentication update. We got to recognize Sergio's, basically his work on multicast authentication. It's a big deal. It's a way of authenticating. You send a multicast and think people authenticate, and then they can get the key to decrypt the multicast. Is really a free open source conditional access system. It's a big deal. You can pay millions of dollars to buy a system like that from a commercial vendor. We're giving it away for free, both the spec and the code. You can take the code, it's in LibRIST, or you can just read the spec and implement. That got us through the most of the big stuff, and now we've been working on what we call ancillary features. The next one was part TL64 Part 1. Source adaptation came up in November 2022, and that adds a very important feature to RIST, which is the ability of a sender to modulate its bitrate based on network congestion. Putting very briefly my Cobalt hat, this is available on Cobalt products, and we're going to be demonstrating it at IBC, but it's not new. We had it for a number of years already, source adaptation. So if the network congests, you bring the bit rate down. Other people are implementing as well. Then we came up with, so that was 2022. And 2023 was a very busy year. We published parts 2, 3, and 5, which the RIST relate's a big deal also. It's a way of traversing a firewall. We added WireGuard support to RIST. So basically, it's a very simple TR to say how you run RIST over WireGuard if you want to use that as security. And then multicast discovery, which is our ongoing commitment to support multicast. So that came in 2023. In 2024, we published receiver synchronization, something that is near and dear to many people's hearts. You have multiple cameras in a facility. You want to get them synchronized at a location. So this is an open standard receiver synchronization. You can synchronize an arbitrary number of senders with an arbitrary number of sources for an arbitrary number of receivers, and all you need is NTP. That came out. I wrote a paper, came out in the SMT Imaging Journal last year with the details. And now we just came up with MPTS program selection. So, which means you can optimize your bandwidth by selecting what you want. So this is where we've been. Long story, but there's 7 years of work to see there. I'll publish, all available in the VSF website, free of charge, you can download and read. Next slide, please. Now we get to the roadmap. So, what are we actually working on right now? Big one is hybrid internet satellite delivery. So the idea here is satellite is very good at sending the same thing to a very large number of locations. But you may know that with 5G, 5G is encroaching on C-band, which is what a lot of broadcasters use for distribution, for contribution, actually. And, okay, you can go to K-band, but K-band has rain fade. So it's not as reliable. What about using the internet to fix the packet losses or the corruption? So that's the thing. Your main transmission is a satellite. Use that for its good, which is sending same thing to one-to-many. And if this side or that side missed something, or there's rain fade, or there's interference, you just fix that to the internet. So we are working on some IPR issues, but if you want to read what's been done so far, I gave a presentation on that at that NABB ITC, and CSI Magazine has an article too coming out at IBC on this. So that's coming. That should be part 7. And then you tie that with the MPTS program selection to just pick what you want. Next one is risk control, which is also a big deal. The industry is struggling with this. How do we control stuff? There's dinosaurs like me who like SMMP, but anytime I say that word, I get hit on the head. So we're looking at something else. But we could have, in the risk stage, we could have rolled a custom protocol for control and be done with it already, but we want to coordinate with industry because there's other efforts, so we are aligning with that. So it's taking a lot longer than I expected, but I think it's going to come out nicely. So we're working with other people, right? You can do things faster if you just stay in your little group, but it's not as good. So it's taking some time, but we're getting there. And there's something else that Sergio is leading, which is congestion control and IRQ best practices. So yeah, you implemented RIST, and anybody can take the TR and implement, but how do you behave, right? So we're writing a paper on that. Don't know it's going to be a TR or just a recommendations paper, but that's coming out. That's coming out along good. And the nice thing, one thing I love about this process is that we all compete in the market. It's people who have their own experiences, but when it comes to the RIST AG, we just freely share everything. And it's for the good of the industry. So that's coming. Next, Wes. So the three things I talked about are things that we are actually working on. And once they are done, what we're going to look at is RIST and WebRTC. Sergio is leading that. RIST and Quick, Adi Rosenberg from our links is leading that. And there's some work being done on that, but we don't know exactly where that's going, but it's coming. And maybe we'll do something there, but it's stuff we're looking at. And that's my speech. Thank you, Wes.
All right, thank you. Let me stop sharing here. Okay, so first of all, like to open it up for questions. If you have a question, feel free to turn on your screen first and then unmute your microphone and tell us, you're free to join us online. This isn't like a webinar where there's a big barrier between us presenters and the audience. So just, be polite and professional, and we'll definitely have a chance to get to your questions. One of the things that I was curious about, Sergio, is can you comment on why it's so important to have security when you are running a RIST system?
Well, the protocol itself is designed to be used over the internet, right? From point A to point B. And while you may have security at both ends, the signal has to go through this, cloud of you don't know what. It could be going through some nefarious router that somebody has hacked and is sniffing traffic. So you have to have a protocol that is resistant to that can go through unsecure areas and retain the end-to-end security. And that's not only the data being encrypted, but the authentication, make sure that somebody's not pretending to be the endpoint for you, a man-in-the-middle attack type of thing. So that's why it's so important to have both, and RIST, has both in it in multiple formats, actually.
Let me make a comment on this, if I
Yes,
may,
please.
Wes. I want to highlight one thing that Sergio said, which is authentication. Security is just all right to encrypt the thing, and it's you can't get to it. But authentication is key too, because if you're a TV station waiting for a reporter to connect and push stuff, is it the reporter that's connecting or is some third party? So that's very important. Sorry for interrupting, Wes.
No, that's great.
Yeah, but
Satoshi,
from a marketing point
yeah.
of view, like a broadcast or like a cinema production, pre-production, that content has to be totally secret. So always they asking such encryption, nobody can hack, nobody can crack. But that security is very important for such transport.
Yeah, it makes a lot of sense. So Ciro, you've been through this process. You've edited all these specifications. So did the RIST folks, the activity group within the Video Services Forum, did they come up with all these great security protocols, or were they utilizing stuff that's already out and available?
It's our AG chairman likes to call it the Lego approach. You use building blocks. So for the security and authentication in particular, we use DTLS, because if you're careful, if you're worried about security, you don't want to hear, "Oh, I just invented something." You want to hear, "It's been vetted. It's been around for a while. Lots of people have looked at it and they say it's good." So in the case of security, we reused the work has been done in the TLS, which is TLS. And TLS is what you use to connect to your bank. You use certificates and use top-of-the-line encryption. So that's the key. It needs to be public. It needs to be vetted. It's not something we design in secret and say, "Okay, it's our thing." Our thing is usually something that is going to get hacked tomorrow. So this one is resisted the test of time.
Yeah, it's amazing to me how creative things are, especially now the attacks that people are doing on the remote controls for people's cars. It's just scary to me what's going on with the key fob attacks and all those other things. So yeah, so RIST is adopting and using a lot of the key protocols that are already available, already tested, already widely deployed, and things that we know are as safe as we can create them to be today, by basing what RIST does on what the other good things that are going on in the internet today. So Satoshi-san, I was interested to get a feeling for the level of effort that was required for 4A to bring RIST into your product line. Was it something that was very easy, open source libraries and things like that, or did there have to be a lot of software written just to get it to work on your platform?
Oh, not at all. So easy. I have to say this in front of Sergio, otherwise he's gonna kill me. But I think it's a RIST protocol is easy to adapt, and then not only easy to adapt into the product, for the customer, easy setup, the RIST tunnel to connect to each other. So that's no harm, no nothing. That's easy implementation. And then open platform, open source, open standard, that's a key for manufacturer to adopt by avoiding as I said, a hidden cost or later some another license fees coming or whatsoever. So in that sense, it's pretty good protocol.
If I put my librist maintainer hat now, I can tell you that most of the time what happens is that the library has some command line applications that let you just grab UDP and push UDP out. So the first time somebody implements a protocol, they go ahead and use those ready-to-made binaries, which we consider in production ready, and they use them as is. They don't have to write a single line of code. They can just put this inside their appliance, their workflow, and start that way. And then eventually, if the application gets more complex and they need to go beyond what these binaries give them, they implement the library directly within their code. We've seen it, being done both ways. Direct implementations are more rare. First, they just grab and get their feet wet. They test the protocol, they like it, and they say, well, now let's leverage more features of this.
Yeah, that makes a lot of sense. And I think you've seen that in other open source applications. So how active is the open source community today with RIST, Sergio?
We have a number of initiatives going in feature set. Particularly, we're working on the adoption of the advanced profile, and all the features that we're working on are a minimalistic version of the RIST relay. The RIST relay specification is quite broad. We're going to start with a smaller version and add those two. to the library, open source package.
Mm-hmm. Well, great. So, Miguel Cristobal, I see you on the call. Would you be interested in unmuting and sharing your thoughts about things? Because I know you're a fairly recent adopter of that. If you're there, feel free to join us here. We'd love to hear from you. So,
Hello, can you
hey,
hear
how
me?
are you? Yeah, do you want to turn on your camera?
Yes, please. Wait a second. Okay. It seems that someone is limiting that. You must
All right.
activate the camera, probably. Okay.
There it is.
There you go. Hey, Miguel.
Hey, good afternoon. How are you?
Good. So you're somebody that's known to the folks here on the call, at least us folks with our video turned on. But why don't you just introduce yourself real quick?
Well, I am Miguel Cristobal. I am the managing director of SAPEC. SAPEC is a company that develop and manufacture a professional video encoder mainly for the contribution area in the broadcast market. All right.
Okay. So are you going to be at IBC?
Yes, we are going to be exhibiting at ABC. We will be in Hall 1C93.
Great. So tell us about how you use RIST in your products.
Well, as I told you, our main market is the contribution, where you need to send the video with very high quality from one point to another. And more and more, we have seen that the customers are demanding lower costs in these contribution links, and they are starting to use internet. And then this is the reason why we implement RIST into our product, into the encoder and the decoder.
Mm-hmm.
And I have to say,
go ahead.
Yeah, I have to say, as someone mentioned before, that it was quite easy to implement. In a very short period of time with the libraries and so on, it was very, very easy to implement.
Mm-hmm. And have you taken advantage of the interoperability? Does your product talk to other people's products?
We are a fair believer of interoperability. We don't believe in proprietary protocols and this kind of thing that make the customer to be the slave of some vendors of manufacturers. We have always defending the interoperability, the standards, and this type of things. And that in that case, this is one of the reasons we decided to use RIST.
Oh, great. So let's talk a little bit about the future of RIST. Some of the things that Ciro mentioned. Is anybody interested in some of those new directions? Is there something that you'd like to get some more information on? You have some experts here. Feel free to ask questions. But if somebody wants to talk, go ahead, unmute and let us know what's going on.
Well, I would like to mention something that I didn't hear in this meeting, that I think is a very nice feature of RIST, is the bonding capabilities. We know that there is a lot of bonding solution in the market, but none of them are interoperables.
Mm-hmm.
That means that with RIST and using bonding, you can be interoperable with other systems. And bonding is something that we have a case study that we will present at IBC, where that allows us to use internet contribution for one customer with two different locations and two different equipment between the origin and the destination. And then using a single link was not possible to do the link because there was a lot of errors and we were in the limit on the capabilities of the link. And then we connect with two links with two different operators, and that allows us to make this contribution in the market. It's a very nice case study.
Yeah. So just for the broader audience, feel free to stay on, Miguel. So bonding means that you're using two separate connections to move your signal over. So, for example, if you were using a wireless provider, in most countries there's 2 or 3 different wireless providers. you send your signal over both wireless provider A and B circuits, and between them, you get enough reliability and enough bandwidth to be able to get your media signals through without having to, overwhelm either one of them. And more importantly, is that it's interoperable in that you don't have to have matching customized equipment on both ends of your link. You can simply use the open RIST protocols to set up your connection and have both both of your streams working nicely together. Is that right, Miguel?
That's right. You made a very nice explanation about that. This was our case. We were using a wireless operator, but the bandwidth was very high because it was a 422 profile. It was around 40 megabit, the bandwidth that we need. Okay, we were almost in the limit of what this operator allow us, and as we were very close to the limit, we got a lot of errors in the link. Then
Gotcha.
we decided to contract another operator, okay, and then we split the bandwidth 60% in the main operator and 40% on the other. In that case, we were able to make a very, very nice contribution link connection.
Sergio, I think you're working in some of that area as well, right?
Yeah, that's an excellent use case. Absolutely, with the library itself allows you to put any percentages, and we did a lot of tests, and part of our normal procedures for validating the library with every build is throw scenarios exactly like the one he's mentioning at it and see how it behaves, and also that is where the new document we're going to publish coming to PA, the best practices. Because everything works well if the link behaves well. What happens when the link behaves, right? How are retransmissions handled? If the protocol is not written correctly or implemented correctly, you can saturate both bonds in his case, if another protocol is used, because the retransmissions are not spaced properly. All this stuff can go wrong. So that's why it's so important also, the implementation and the best practices on how to use the protocol itself.
And I would like to make a comment on this. RIST is not necessarily limited to two lengths. You can use as many as you want. And the other thing that is important to say is with the source adaptation, the source adaptation TR, you are allowed to actually dynamically change the spread between the links as things change. You don't necessarily need to change the bitrate of the encoder. You can change the spread of the signals. In part, the TR gives you enough information to make that decision.
So we have a question. Go ahead.
No, I was just confirming that Ciro is right.
Yeah. So here's a toss-up question from Del Clausen. Do you think that RIST and SRT will ever merge? And let me just start by saying that's really not up to us. The folks that have been working on RIST for 7 years now have always been very open. Anybody can use our protocols, and anybody is welcome to build versions of their systems based on our protocols. We have made a conscious decision not to implement features of other protocols that we don't think have the best performance, or are necessarily the most optimal way of doing things. It's not really something that we have a lot of control over. Anybody else want to say anything?
Yeah. Haivision was an early participant on the RIST AG, and they even proposed SRT as the beginning of the RIST, and we, for a number of reasons, didn't go that way. We kept them informed that they came to a few meetings, but it's, as well said, it's really not up to us. They can implement, and I see that SRT is adopting some of the features of RIST, but as if you want to look in the wires, protocols are concerned, they are fundamentally different. So merging from a technical standpoint is just not possible. From a marketing or engineering standpoint, and one can evolve into the other or something like that, or get a new mold or something. But again, it's not up to us.
So one of the things that is interesting, that if you do a little searching around the web, yeah, you can find videos and explainers and stuff like that. It is possible to send SRT streams over RIST tunnels. You can set up a highly reliable, secure RIST tunnel, and then you can feed your SRT traffic, and that actually, in some cases, improves the performance of the underlying, of the SRT end-to-end connection, because it has a cleaner pipe with less retransmissions and things like that. And the beautiful thing about RIST is that it's an open book. You can read literally every line of specification that exists for it is on the VSF.TV website. Everything that RIST does is defined there, and anybody that implements it is free to put their own enhancements on it. So, for example, if you have a way of figuring out how to distribute the bandwidth between different links, you can tell RIST how to control its bandwidth so that you optimize the throughput on the system, like Miguel was talking about, the 60-40 split. You're free to do that. And the protocol, because it's open, doesn't interfere with your ability to do that. It doesn't try to do things. And one of the things I'm really looking forward to is this best practices document, because I think that's going to help open a lot of eyes as to what really is possible with the RIST technology set. So Sergio, get working.
Yeah, great.
Okay. Anybody else have any questions, or anybody want to have any closing comments? Let's go in reverse order. Ciro, anything you want to say? What booth are you gonna? Where's your booth at IBC?
Cobalt's gonna be at 10.B41. We're going to be showing a whole bunch of stuff that's not RIST related, but everything that we have that has a transport stream interface supports RIST. And I'll have a live stream from Champaign, Illinois, through a cell connection into the show floor with source adaptation. But
go ahead.
That's just my marketing pitch.
It's funny. I have to say, I remember going to the NAB show in Las Vegas back in, I want to say, the mid to late 90s, and not even being able to get a cell phone call through. The systems were so underpopulated and so slammed with people showing that you couldn't literally even make a phone call to somebody. I think it's amazing that we've gotten to the point where we can send live video on the show floor at these big events. It's a lot of infrastructure, but a lot of innovation too.
Yeah, and between you and me, we use a cell router because the amount of money they charge for internet in those shows is abusive.
So you free phone calls at Cobalt? That sounds good.
Yeah, yeah, walk around the Cobalt booth. We'll give you the Wi-Fi password. You can use our internet. But I like to say, I mean, now I'm going to put my RIST farm hat and say that it's a great group of people. We're very open. We share. When Miguel implemented RIST in his products, we did an interop with Cobalt, which is a different stack than LibRIST. And I kid you not, took 15 minutes, right, Miguel? And everything just worked.
Yes, that's true.
So we help each other. I mean, we compete in the market. He makes encoder, I make encoders, but when it comes to this, we're doing it for the industry, and that's the right attitude.
Thanks, Ciro. Satoshi-san,
Yeah.
any closing words? Remind us where your booth is.
Well, I just want to mention again that the REMI application for this is just RIST is a revolutionary because as I said, the 10 stream all together in sync. So you can have 10 camera feed on location, sending over to anywhere you want. Location have a switcher. Then you can get the switcher, all sync up together. You can do the switch. And then even bi-directional function on RIST, so you can monitoring purpose or confidence monitor back to the location. That can be done all sync with audio. That's just revolutions for such REMI applications. And as I said, such great openness of the forum. So adding a new feature set, even ST2110 is ready to go. So maybe we're gonna ask other format, other codec, other things is coming to the technology that's open forum can accept to implement, step by step. So I think, Ciro or Sergio or, Wes, everybody very open mind, listen to what the pain point customer was, and then they try to implement at no license fee. That's revolutionary. That's a RIST, I think. Thank you, Wes.
And what booth are you going to be at?
Okay, yeah, I gotta remember. It's a stand 2B50. So
Great.
you can see the revolutionary encoder decoder through the RIST tunnel at IBC.
Excellent. Sergio.
All right, we're going to be at 5F43, and I do invite anybody that wants to talk about the Libris library, any pain points they have on implementations, talk about the protocol itself, just come on over. We're going to have the people there to answer any questions regarding the library as well. So
Great. And Miguel, you want to just tell us where your booth is? And
yes, as I mentioned, it will be in the hall 1. The booth will be the C93. And we will be exhibiting our encoder Laguna with multiple channels and supporting RIST, is the product we have right now. And we also is showing our low latency RIST encoder CBAC1. Okay. Something that I want to mention is something that Satoshi mentioned. Is one of them is the synchronization between the audio, video, and the different cameras. This is quite important. But also very important with RIST is that we are over the public internet. We are sending video over the public internet. Latency in the public internet can vary from time to time. But if you are using RIST, you can fix this latency to be deterministic in a fixed data. And that could be very important for REMI productions, as he mentioned. And latency, I think, is another good point for RIST.
Absolutely. Absolutely.
And Ciro, remind us again, when is the RIST meetup?
Yes, I was going to invite everybody. The RIST Forum Cocktail Hour at IBC, and I'm reading over here, is Saturday, September 14th at 5 p.m. at the SipRadius booth at 5F43. So, and I think we're going to do the Libris meetup at the same time. So come have a drink with us. Again, September 14th, Saturday, 5 p.m. at the SipRadius booth.
All right. Well, I'll be at IBC, floating around to various places. I don't have a booth, but I'll be sure to be there at the RIST meetup on Saturday. And for everybody who's joined us on the call today, thank you very much. Appreciate your time. And again, my name's Wes Simpson, and looking forward to seeing you in Amsterdam. Take care, everybody.
Thank you.
Take care. Bye. Thank you.